MS Ramaiah University of Applied Sciences.
Hello friends, with this experiment we are determining the splitting tensile strength of molded concrete cylinder. Apparatus: compression testing machine, standard cylindrical mold, jig and other accessories. The tensile strength is one of the basic and important properties of the concrete. The concrete is not usually expected to resist the direct tension because of its low tensile strength and brittle nature. However, the determination of tensile strength of concrete is necessary to determine the load at which the concrete members may crack. The cracking is a form of tension failure. The splitting tests are well-known indirect tests used for determining the tensile strength of concrete, sometimes referred to as split tensile strength of concrete. The tensile strength is about 10% of compressive strength. Procedure: calculate the required quantity of materials and weigh the required quantity of materials, that is cement, sand, fine aggregate, coarse aggregate and water. Mix the dry constituents thoroughly to get a uniform color. Clean the cylinder molds and oil it completely. Then add water to the dry mix and mix it completely to get a uniform color. Pour the concrete into the cylinder molds in 4 layers and tamping each layer by 35 times using tamping rod. Struck off the concrete on the top of the mold. After casting, keep the cylinder molds for air drying for about 24 hours. Then remove the concrete cylinder from the molds and keep it for curing about 28 days. The specimens are tested for required number of period for about 7 days and 28 days. The load shall be applied without shock and increased continuously at a rate of approximately 140 kg per square centimeter per minute until the resistance of the specimen to the increasing load breaks down and no greater load can be sustained. The maximum load applied to the specimen shall then be recorded, and the appearance of the concrete and any unusual features in the type of failure shall be noted. Data collection and tabulation is as shown in the table.
Hi students, the third test what we are going to do is the split tensile strength test. The apparatus required for conducting the split tensile strength are the compression testing machine along with the split gauge. So the cylindrical mold having a diameter of 10 cm and height of 20 cm. There is one more standard mold available which is having a diameter of 15 cm and the height will be 30 cm. The second step is preparation of mix. As of now we taken 2.5 kg of cement, 5 kg of fine aggregate and 7.5 kg of coarse aggregate, which comes to ratio 1:2:3. We generally do it for M20 grade concrete. For the first trial, I am considering the water cement ratio as 0.4. We start mixing the concrete. First, what we are going to do is we make sure that the concrete mixer is on the inner side, it is smeared with the oil. So first what we will do is we add the coarse aggregate. So we are going to add the coarse aggregate to the concrete mixer. After coarse aggregate, the fine aggregate will be added. After this, the cement will be added along with the water which is prescribed for this particular mix. Add the water. We are pouring the entire mix of concrete onto the tray. After preparation of mix for split tensile strength, what we are going to do is, we are going to make use of the cylindrical mold. What we are using here is a 10 cm dia and 20 cm height cylindrical mold. The standard is 15 cm dia and 30 cm cylindrical mold. What we are going to do, we are going to put this concrete, freshly prepared concrete, in 3 equal layers with 25 number of tampings to each layer. Here we are using a vibratory technique, so I am just putting the 1/3 layer and giving a vibration. I am adding the second, third layer. Now we are going to add the final layer. I am going to finish the surface. So I just finished the surface. What I am going to do is, I am going to retain this mold for 24 hours. After 24 hours I demold this mold, and I am going to keep the specimen for 28 days in water curing. After casting the specimen for split tensile strength, what we are going to do, we are going to unmold the sample and keep it in water curing for 28 days. After 28 days of curing, we are going to get this particular sample. So this is a cylindrical concrete specimen. So the dia of this is noted and the length of the specimen is noted. So what we are going to do, we are going to place this into the compression testing machine, not along the length, we are going to place it on the diametrical axis. Then after coming to this, we are supposed to enter what is the type of specimen we are using. We are using a cylinder. Enter the diameter of the specimen. Okay. So enter the length. Okay. Next what we are going to do is, we are going for the compressive strength. The operating mode. Here we are going to take it for the compression once again. Okay, it tells you what unit you want to do it. I want to do it in SI unit. It gives you what is the maximum capacity Okay, we need to close the door of the thing, and we should lock the load valve, release the emergency button, and give a command of run. When I give a command of run, what happens? The load is going to apply. So once the specimen fails, what you are going to get? You are going to get a peak load. Okay, as I already given the parameters, you can calculate the this we are going to note down as P. Using the formula, you are going to find out the split tensile strength of the concrete. The beauty of the thing that you are supposed to observe over here, so the specimen is going to fail along the diametrical axis. So I'll just open this specimen and show you how it is going to be there. If I just remove this particular specimen, so you observe the beauty of the specimen. This is going to fail on the diametrical axis. If little load is applied, this exactly is going to be as a 2 equal halves. This is going to be the 2 equal halves. This is what we call determining the split tensile strength of the concrete. Okay, so this completes the determining the split tensile strength of concrete experiment.
At MSR UAS, we spark your imagination unlike any other.